Good day, everybody. For our video today, we're going to talk about conservation of momentum. So, our lesson will be related to our last topic about momentum. Now, in the previous lesson, we have known that in order for an object to accelerate, an external force must be applied. Similarly, if you want to change the momentum of an object, an external force is also required. What do you think happens to the momentum of the billiard balls when they collide with another balls? Is there a gain or loss of momentum? So if your answer is no, then you are correct. Momentum is conserved. So if the m or mass value and the v or the velocity value remain the same, the momentum value will be always constant, which explains that the momentum of an object or set of objects remains the same when left alone. Take note, class, that momentum is defined as mass in motion. And take note also, class, that the law of conservation states that in a closed and isolated system, the total momentum of the objects before and after collisions are equal. And speaking of law, if you would recall the Newton's third law of motion, it states that for every action there is an equal yet opposite reaction. So when the cue ball travels towards the other ball, it carries some of the momentum with it. The rest is transferred to the second ball. Therefore, none of the momentum was lost, only transferred. So using an equation, we can say that the P initial or the momentum initial of an object is equal to the final the final momentum of an object. Remember, class, that momentum is equals to the product of mass and velocity. Let's say, for example, these two children on a skateboard. So kapag tinulak nila yung isa't isa, they will move into different direction, one to the left and one to the right. So it explains that the force that the girl exerts on the boy and the force that makes the girl move in the other direction are equal magnitude but opposite direction. Therefore, the total momentum of the two children here does not change. Take note, class, that the velocity and the force are both vector quantity. Now let's have this problem solver number one. So we have two cars with one mass of 1,500 kilograms and the other with a mass of 2,000 kilograms initially at rest collide. After the collision, the 200-kilogram car moves backward with a speed of 5 meter per second. Find the velocity of the 1,500 kilogram car after the collision. So we're looking for the velocity, class. Take note. So again, let's first identify the given of the problem. So we have the first given, the mass of the car A is equals to 1,500 kilogram. Mass of the car B is equals to 200 kilograms. The initial velocity of the car A is 0. Take note, class, that it's stated on the problem that both of the cars were initially at rest when they collide or before they collide. So the initial velocity of the car B is 0 meter per second. The final velocity of the car B is negative 5 meter per second. Take note, it is negative. That is because it moves backwards. So the negative sign there is an indication that the object or the car is moving backward. So to solve our problem, of course, we have identified the given and now we're going to substitute the given values of the problem. So for our formula, we have the m1 v1 plus m2 v2 for the initial is equals to m1 plus v1 or the mass 1 or the velocity 1 plus the mass 2 or the mass of the car B times the velocity of the car B for its final. So we have here for the mass 1,500 kilogram for the car A, multiplied to 0 meter per second for the car A as the substitute value for the velocity 1 or the velocity of the car A, plus the 200 kilogram of the car B for mass of the car B, and then substitute also the value of the velocity of the car B. Take note, class, we're still on the initial part on the substitution. Initial part of m1 times V1 plus M2 times V2. Now, we substitute naman dun sa final values. So, we have the 1,500 kilogram for the final mass of the car A, and then we're looking for the X here indicates class that we are looking for the final velocity of the car, and then we're going to, plus 2,000 kilograms for our M2 and negative 5 meter per second for the car B. So, computing these given values, since we're looking for the final velocity of the car, we're going to transfer that on the other side. Then divide both sides by 1,500 kilogram, then retain the velocity 2 is equals to 10,000 kilogram meter per second. So if you would ask me, where did I get this 10,000? That is 10,000 class. I apologize. Nag-error lang. Now, if you would ask me, saan ko nakuha yung 10,000? This is 10,000 class. Yung nakikita nyo 100,000. That's typo. 10,000 po yan. Saan ko nga ba nakuha yun? So, if you would multiply 2,000 class times 5, that is 10,000 kilogram meter per second. Now, bakit hindi siya naging negative? Again, class, the negative sign is just an indication that the car B is moving backwards. If you would divide both sides with 1,500 kilograms, so we're going to cancel the 1,500 kilogram here, and then this 10,000 kilogram meter per second will be divided also by 1,500 kilogram. Then for our velocity 2, we have the 6.67 meter per second. Therefore, the final velocity of the car A is 6.67 meter per second. Now let us talk about also collisions. So collisions is an encounter between two objects resulting in exchange of impulse and momentum. Take note, class, that in any collision there must be a conservation of linear momentum, but this can be expressed itself in variety of ways depending on the type of collision. So collisions are categorized according to whether the type of kinetic energy of the system changes. So, kinetic energy may be lost during collisions when it is first converted to heat or other force like binding energy, sound, light, if there is spark, etc. And also, if it is spent in producing deformation or damage such as when two cars collide. So talking about collisions, we have two types of collision. We have the elastic collision and inelastic. So we're going to discuss first about the elastic collision. So for elastic collision, it is defined as one in which the total kinetic energy of the system do not change. Colliding objects bounce off after the collision. Simply, we can say that after collision, two objects that are involved will go separated each other. So this collision, the total kinetic energy and the momentum is also conserved. So with that saying, that means that there is no loss of momentum and thus conservation of energy is applied. So if you would see the picture, or that means we have stated there that momentum after and before are equals. Now, the second type of collision is the inelastic collision, in which the total kinetic energy of the system change. Example, when it is converted to some of the form of energy. So, objects that stick together after collision is said to be perfectly inelastic. So, kung ma-observe nyo dun sa ating video, two objects just collided to each other. So, that means they are perfectly inelastic. So, one example for this inelastic collisions are, so the best example for this inelastic collision are the asteroids. So the asteroids, they perfectly collide to form another butt. So that's it. That's the very short lang po siya, and then that is just a continuation of our lesson about momentum. So I hope you have learned lesson, class. Thank you.